Okay, good morning, afternoon, or evening, everybody. Welcome to the Discover NASA's Near Real-Time Data Using LANCE webinar. This is your host, Jennifer Brennan. It is 2 p.m. Eastern Time, so we're going to go ahead and get started here. And what I like to do first is go over just a few webinar logistics. To ensure the best audio experience, participants have been placed in silent mode. But if you have any issues or you have any questions, what I'd like for you to do is enter those into the Q&A pod, and you'll find that located on the lower right-hand side of your screen. This works like a chat. Today's webinar is being recorded. The recording will be posted to our online Adobe Connect webinar catalog, as well as to our NASA Earth Data YouTube channel, and there'll also be a link provided on the NASA Earth Data website within a few days of completion. Once completed, I will send an email to all registrants with the recording links. As far as timing is concerned, today's webinar will be 1 hour long with 45 minutes allocated to the presentation and demonstrations and an additional 15 minutes for the question and answer period. During today's webinar, we will have two speakers, Karen Michael, who is the System Manager of the Earth Observing System Data and Information System, or EOS-DIS, and the Land Atmosphere Near Real-Time Capability for Earth Observing Systems, or LANCE Manager at Goddard Space Flight Center. Our second speaker today is Diane Davies. She is the NASA LANCE Operations Manager. Once our speakers for today have finished with their presentations, what we'll do next is we'll transition to a final optional set of polling questions. Excuse me. We'll give these questions about 3 or 4 minutes or so, and then from there we'll move directly into the Q&A period. Depending upon the volume of questions that we receive, we will extend the Q&A period an additional 15 minutes from end time for those of you who may wish to stay on the line, but we will have a hard cutoff at 3:15 p.m. Eastern. So what I'd like to do next is pull up today's agenda. Give me just 1 second here. Hopefully everybody will be able to see that. All right. Excuse me. We will begin today's webinar with Karen Michael. She'll provide some background information for NASA LANCE as part of her introduction, and then we'll also define the difference between NASA near real-time data and standard data products. From there, we will transition to our second speaker, Diane Davies. She will describe the available data products and also go through a series of demos that showcase how you can discover and access LANCE near real-time data and imagery. And then finally, we will wrap up with some examples of how LANCE data are being used. With that, it is my pleasure to introduce today's first speaker, Karen Michael. Karen, and let me pull up your slide deck here, and we should be.
Okay, thank you, Jennifer. Welcome, everyone. I'm glad you could attend. Okay, so as Jennifer said, first of all, I'm going to talk about what is LANCE and why was it started. What do we mean by near real time? What's the difference between near real time and standard products? What near real-time products are available, and then I'm going to turn it over to Diane Davies, who's going to show you how you can access LANCE data and imagery. She'll be covering various methods of access, which include Earth data search, website links for download, the Fire Information for Resource Management System, or FIRMS, and the Global Imagery Browse Services, or Gibbs, and the imagery browsing tool Worldview. She'll also be covering LANCE applications, who uses LANCE and what for. And I should also mention that the logo in the left corner represents the 10-year anniversary of LANCE, which we celebrated in 2019. Okay, so what is LANCE and why was it started? NASA is well known for providing high-quality satellite data for long-term science research, but application users, operational agencies, and even researchers need data much sooner than routine science processing offers. So to meet these needs, NASA developed the Land Atmosphere Near Real-Time Capability for EOS, or LANCE. EOS stands for the Earth Observing System. LANCE provides imagery and data for near real-time applications, such as air quality, dust storms, fires, vegetation for agricultural monitoring, floods, ash plumes, drought, smoke plumes, sea ice for shipping, and severe storms. So it all started in 1999 with the launch of NASA's Terra satellite, known as the EOS flagship. Shortly afterwards, in 2000, there were huge wildfires in Montana, and the United States Forest Service reached out to NASA and the University of Maryland to see if there was a way to get near real-time imagery to help fight the wildfires. The Earth-observing ground systems were designed for scientific research products, and they weren't really required to provide products in a rapid turnaround fashion. So products were taken on the order of 1 to 2 days. The University of Maryland were a part of TERA's MODIS science team. MODIS stands for the Moderate Resolution Imaging Spectroradiometer, and they developed a fire detection algorithm. So this partnership led to the development of the MODIS Land Rapid Response System, which was later just known as Rapid Response. And that would initially provide data within 5 hours of satellite observation. But following the attack on September 11th in 2001, there was a sudden need for near real-time observational capabilities to support the forces in the Middle East. And that spurred the creation of a whole new system called the Near Real-Time Processing Effort, or NRTPE. Initially, MODIS Rapid Response was used for wildfire management only, and it was limited to just to North America. But it soon became clear that there were so many other near real-time applications on a global scale that could benefit from the timely data, such as severe weather events, dust storms, oil spills, and volcanic activity. So in late 2001, early 2002, NASA, NOAA, and the Department of Defense, which were partners in the National Polar Orbiting Operational Environmental Satellite System, known as the MPOS program, collaborated to build the NRTPE. So this was a risk reduction effort meant to familiarize future application users with satellite data, and it was aimed at the military, weather agencies, and first responders. So initially the latency was 5 to 7 hours, but several improvements were made along the way, and eventually the latency was reduced to 3 hours by adding additional spacecraft contacts, prioritizing the return of the data from the ground stations, and further modifications to the algorithms and their inputs. The system was located at NASA Goddard Space Flight Center and operated by NOAA. Initially, it processed MODIS data from the TERA satellite, but following the launch of Aqua in 2002, it added processing for a second MODIS instrument. They also added processing for the Atmospheric Infrared Sounder, or the AIRS instrument. So from its initiation following September 11th, the NRTPE was quickly built, and it was used heavily in Afghanistan and in Iraq. Dust storms were a real issue, and the Naval Research Lab developed dust-enhancing algorithms in order to better distinguish the dust from the clouds in the smooth desert background. They also developed a satellite focus web page to make it easier for troops who were untrained in the use of satellite data to utilize the data. And this was a real game changer that put data in the hands of decision makers who were trying to decide whether it was safe to take off and land on the naval aircraft carriers, as well as for troops on the ground in the Middle East. The group was recognized with a NASA award in 2004. And this was an incredibly motivated, badgeless team focused on a common goal. And it was really amazing for me to see how much they accomplished in such a short period of time. So as the NRTPE system aged and the demand for the data grew, the data flow became less reliable. The NRTPE was also heavily relied upon by the rapid response system, and the rapid response imagery was increasingly being picked up by the media. As the rapid response capability became more visible, news organizations such as CNN, BBC, Washington Post, and New York Times began requesting custom georeferenced images for large newsworthy events. As the original system aged and the demand and expectations for near real-time data increased, the NASA Earth Science Division at headquarters decided that a new system was needed. But without the budget to build a whole new system, NASA decided to leverage the existing standard science data processing systems who were creating the standard research products to start producing the near real-time products. So in September of 2009, LANCE was born, serving data from now 3 EOS satellites following the launch of the ARA satellite in 2004. So the 5 instruments were the MODIS instrument, both on Terra and Aqua, the AIRS and AMSR-E instruments, both on Aqua, and the MLS and OMI instruments, both on ARA. So our approach was to leverage the existing systems to keep the cost down. We kept the 3-hour latency from satellite observation as a goal, and NASA not being an operational agency like NOAA is, we made redundancy requirement in order to assure availability, and we made all the elements of LANCE conform to the same requirements so that it looks like one system to the users. There's a single LANCE landing page where all the products can be accessed. And we also established a user working group to advise the LANCE management on new products and services. Then in 2011, 2012, 2 new developments were born out of LANCE. The Global Imagery Browse Services, which provides over 900 imagery layers and many available using LANCE near real-time data. And also the Worldview, which is a web-based imagery browsing tool that uses Gibbs to supply the imagery. Worldview was built with the LANCE user community in mind. Gibbs and Worldview were also game changers in the way near real-time imagery were distributed and used, allowing for quick and easy access to daily global imagery without significant delay. The Fire Information for Resource Management System, or FIRMS, was developed in 2007 by the University of Maryland, and it was merged into LANCE in 2012. FIRMS provides users with MODIS and VIIRS-derived hotspot active fire locations. VIIRS and Visible Infrared Imager Radiometer Suite is what VIIRS stands for, that is now flying on 2 satellites, the SUMI National Polar Orbiting Satellite, or SNPP, and the NOAA 20 satellite. Also, while Rapid Response was initially started providing only fire data from North America in 2007, it was providing true global subsets of data from MODIS. And as I mentioned before, it was really popular with the media, and it was merged into LANCE in 2011. The user predetermined subsets were then replaced with Worldview Snapshots in 2019 as a new low bandwidth interface that provides a selection of popular imagery layers. The users can select custom bounding boxes and imagery layers, and they're allowed to save their preferences with a URL and then come back to the URL to retrieve the imagery of their choice. So since its inception, LANCE has expanded to include JAXA's GCOMW AMSR2 when we lost the AMSR-E instrument on Aqua. We've also added the LIS instrument, which flies on the International Space Station, the MISR and MOPPET instruments on Terra, and the VIIRS and OMS instruments on SNPP and NOAA 20 satellites. And as you can see at the bottom of this chart, we're continually adding new products as needed and also as resources allow. Along with the expanded missions and instruments, we continue to add or leverage additional science processing facilities for LANCE, like the National Center for Atmospheric Research, or NCAR, in Colorado, the University of Wisconsin, and the NASA Langley Center in Virginia. Okay, so what do we mean by near real-time, and how are near real-time products different from standard? Before I talk about that, I just want to define what latency means. Here, latency is defined as the time between satellite observation and the data being available to the end user. So as you can see in this table, near real-time is 3 hours or less from satellite observation time. And to compare that with standard products, they have a much wider range of latencies from 8 to 40 hours, or sometimes up to months for some products. Standard products are intended for scientific research, so they wait for the most accurate ancillary data or input data to become available. So that could take hours or days or weeks in some cases, while near real-time are intended for quick turnaround for decision makers who do not rely upon the highly precise data. Numerical weather prediction centers, for example, cannot wait any longer than 3 hours for their data. So to achieve the 3-hour latency requirement, LANCE data are expedited at every step of the way, from data capture to processing and distribution. Latency requirements necessitate the use of predicted geolocation data and relaxed ancillary data. In some cases, there are significant differences between the near real-time and standard science quality data products. but overall the agreement is pretty high. So for example, while an untrained eye might not be able to see any difference in the land surface reflectance image, which is the true color images above, however, you might be able to see differences in the cloud top temperature in the lower images. The key difference between near real-time and level 1 products and those for standard processing are the data that is used to determine the geolocation. Standard products use definitive geolocation, attitude and ephemeris, data that is provided daily, whereas near real-time products use predicted geolocation. In the case of Terra satellites, this is provided by the instrument's Global Positioning System, or GPS. Aqua and Aura satellites do not have an onboard GPS, so for immediate processing, it requires spacecraft housekeeping data and predicted ephemeris. And to give an idea of the impact, the difference between MODIS geolocation when using definitive versus predicted attitude and ephemeris is routinely less than 100 meters. However, some situations, especially during or after spacecraft maneuvers and during space weather events, the differences can increase up to several kilometers. And level 2 products can be thought of in 2 categories. The first is level 2 products that do not make use of ancillary data in the algorithm. These products use the same algorithm code as that is used for standard processing. The second group of level 2 products are those that require ancillary data. So these products have relaxed requirements for ancillary data. So if latency is not your primary concern, you're encouraged to use the standard science products, which are created using the best available ancillary calibration and geolocation information. So now I'm going to turn it over to Diane Davies, who is going to walk through what near real-time products are available and how you can access them.
Great. Thanks, Karen. I hope you can hear me okay. All right. So, so Karen's already said that we provide data from 10 instruments, and I just put a couple of charts in just to remind you which platforms and or satellites those instruments are on. So that's the first chart, and then the second chart I'm going to show lists the instruments and the product categories. It also provides information on the year the products were added to LANCE, the average latency time in minutes, and the number of products available as data products and also as imagery products. And you'll see there's a lot more imagery products than there are data products, and that's because quite often you can view the data set in multiple imagery layers. So in terms of accessing data, by data we're generally talking about the hierarchical data format, or HDF, or NetCDF. And these are archived for 7 to 14 days on LANCE. And for all data sets, you need to be registered with the Earth Data login. If you're not familiar with that, it's a fairly simple process. You register once, it's free of charge, and then that Earth Data login can be used across all of the different data centers. So if you know what data you're looking for, then you could go to one of the LANCE web pages. This can either be one of the LANCE element web pages or the umbrella page that Karen was talking about, and I'll show you. You could also search on the Earth Data search, or if you're interested in the active fire or hotspot information in GIS or text format, then we would recommend that you go to Firms. If you're not sure what you're looking for, then we'd recommend that you take a look at the LANCE Hazards and Disasters page or search visually in Worldview. So this is the landing page for LANCE. Karen's already showed this briefly. I just want to show you that from here you can access, you should be able to access everything that you need. So from the top menu, there is a header, and you can see here that you can link through to the Earth Data search. Let me just put on my pointer. Okay, here we go. You've got the Earth Data search up here. From here, you can also access various links. So you can see that we've got links to data, imagery, and then there's various resources here, including more information about LANCE, the Earth Data login, more information on the differences between the near real-time and standard products, and information on mailing lists that you can sign up to if you want to know about data outages. There's also information on disclaimer and citation. So here we've got a table which provides quick links to the various data products. If I were to click on AMSA here, you'll see that I go to a page like this. There is there's an instrument page like this for all of the different instruments within LANCE. And again, there's quick links to the other instrument pages here on the left-hand side. All of the pages contain HTTPS links. So again, you can click on these. You need to be downloaded. You need to be registered. You need to be logged in Earth Data to be able to download the data. All of the pages provide a description of those data sets. And if it's available, there may be some additional information such as user guides or recipes. And then you get the volume and a Worldview browse image if it's available. Okay, and then I'm going to transition across now to give you a demonstration of the hazards and disasters page. So I think Jennifer's going to load that for me. Thank you, Jennifer. All right, so you can get to the hazards and disasters page by clicking on the link at the top right. Just waiting for the movie to show up on my screen. Here we go. So clicking on the top right here, and that will take you to the hazards and disasters page. And Karen's already talked about these various applications. If you were to click on ash plumes, for example, it will take you to a page where we list all the data sets that we think are potentially useful for viewing ash plumes. So here I'm going to click on Aerosol Optical Depth. And again, the table format is very similar. You've got a download link, a link to a description of the data, and various image links in Worldview. And at the bottom of every page, there will be an example of an event. So in this case, we're looking at the Reprojection volcano, which erupted on the Kuril Islands in Russia in June 2019. And you can also, there's a link there to Worldview, so you can view this data set yourself if you want to. And you can see the day before there was nothing to see. It was a very dramatic event. And you can, okay, so that's that. And then I'm going to show you now, I'm going to switch to another movie, and I'm going to show you the Earth Data Search client. So this is a client, it's an ESDIS client, and you're able to search here for near real-time and standard quality data. So if I just, sorry, lost my mouse, just press play. Okay, there we go. So here you can see there's over 6,000 collections of data. If you want to just limit it to near real time, you can select the near real time button here, and it will reduce the number of collections. My movie seems to be. You can type something in the search box. So here I'm going to look on aerosols. I've selected near real time, so you can see that there's only 228. I'm going to select the instrument. I'm going to look at VIAs, and you can see there's 3 matching catalogs. And here I'm going to look at the aerosol deep blue product. This is great for looking for granule search. You can see the different granules that are available here. You can see that the Gibbs imagery shows up here. I'm interested in this particular granule over northern India because it's got high aerosol values. And you can see the start and end time of the granule. So that enables me to look down here and see which granule I'm most interested in. Here we are, that's the granule. And I can just click on this download link here. You'll see that this will take me through to Earth Data login. And once I'm logged in, then the data will start to download, and hopefully you can see that in the bottom left-hand corner. So those are 2 ways to access the data product. I'm going to switch gears a little bit now and talk about firms. So Jennifer, go back to my slide. So firms, as Karen has said, it's a component of LANCE specifically set up to visualize and serve active fire and thermal anomalies data in easy-to-use format. So on the first slide, this is an example of some of the fires in New South Wales from November 2019. And here you can view, in firms you can view the imagery, receive email alerts, or download the data in easy-to-use format. And there are 2 different landing sites for firms. Karen talked about the Earth Data umbrella, but the elements that provides the data is LANCE Modus, and so there are 2 different landing sites. But whichever site you go to, you will still get access to the same services. So the fire map, the active fire data, the alerts, the download tool, and the web services. And before I go any further, I just wanted to take a moment to look at what a hotspot or an active fire detection means on the ground, because this is one of our frequently asked questions. So the satellites take a snapshot of the events as it passes over the Earth. So each hotspot or active fire detection represents the center of a pixel flagged as containing one or more fires. So here we are on the top here, we've got what the satellite sees. So you can see that there was a fire observed in this pixel, and this shows up as being flagged as a pixel here. But in this second example, we might have 2 fires detected within a pixel, but it still only shows up as 1 fire. And here we have 1 large fire which saturates 4 pixels. So for MODIS, the pixel size is approximately 1 kilometer. But for VIIRS, we use a 375 meter product. So it's much smaller, and it enables us to get it also picks up much cooler fires, and because it's much smaller, it's much more accurate in terms of mapping the distribution of a fire or how a fire event unfolds. And we have this example here from Wilfried Schroeder from NOAA, who was at the University of Maryland. It's from the Tame Ecological Reserve in southern Brazil from March 2013. And the main things that we're interested in here are the image on the left and the image on the right. So the image on the left provides active fire detections from MODIS using the 1 kilometer pixel, and the one on the right is the VIIRS 375 meter product. And the different colors represent the Julian days. So the fire started using the purple, Julian day 85, and then goes through to the dark red. So you can see that using the aqua MODIS, it's very difficult to see how the fire spread, but with the VIIRS, it's much easier. So it's great that we have that data set now in firm. And this is just a screenshot of the fire map. You have these on the top right. Here we've got quick views. Trying to drag my cursor down. Never mind. We've got quick views at the top. You can see we've got these different fire layers. You can also, if you scroll down on the right-hand side, you get the option to add in the Gibbs satellite imagery that we've been talking about. So here we are looking at the VIIRS corrected reflectance imagery, the true color. And I don't know if you can see, but down here in Western Australia, so I'm having difficulty using my mouse. Down here in Western Australia, there we go. There's a bunch of fires down here. So if we zoom into those, you can see that there are a lot of fires. And if we use this identify tool from the bottom here, you can click on the fires and get the attribute information, such as the center coordinates of those pixels, as well as the acquisition time and date, and some other information such as the confidence and fire rated power and brightness temperature. So it's great to see the active fires, but if you're really interested in that burnt area, you might want to, you can't really distinguish in this image between the burnt area and unburnt area. But if we load the 721 corrected reflectance imagery, this is much better for distinguishing burnt area. So here, hopefully you can see that the burnt area is showing up in brown, and the unburnt area is showing up in green. Okay, and then I just added this slide. I've turned the VIIRS and MODIS imagery off just to show the different pixel sizes. So as you zoom in, it retains the spatial integrity of the MODIS and VIIRS imagery. So the red is the VIIRS imagery, and the pixel size is smaller than the MODIS imagery. So through firms, we also have kind of quick links to make the data available as shapefiles, KML, or text files. We also have this Fire Alert subscription service, which is free. You can choose to get near real-time daily or weekly alerts by country, custom region, or protected area in English, Spanish, or French. And this is just a screenshot to show the map. If you want to draw a polygon of your area of interest, you can either do that as a custom box or your polygon. And I'm going to talk a little bit about Worldview and Gibbs now. So Karen has already described these products. They provide a visual first approach to finding and using Earth observations. And on the right-hand side of this image, we have a cake, which one of our colleagues made. And it's quite useful as it really shows how the global mosaic is chopped up into a tile pyramid, which then makes, these tiles are then pre-generated, which makes it very quick and easy to zoom through and view the imagery in a highly responsive manner. So when you go to Worldview, the first thing you'll come to is this welcome screen, which has a bunch of story tours. And if you're not familiar with Worldview, I would highly recommend that you take a look at these story tours. They provide, they look at different events, and they provide information on what imagery layers are most useful for viewing those events, as well as providing hints on the different tools that Worldview has to make viewing those events much easier. So, and I'm going to show you some of those in a moment. But first, if you want to add your own imagery layer, then you would click, if I can get this mouse to work. Okay, down on the bottom left-hand side, there's an orange, thank you Jennifer, an orange add layers, just up here. There we go. And the first thing you would see is they categorize the imagery by hazards and disasters. So this page is very similar to the LANCE hazards and disasters page that I showed you. There's also the option of looking at science disciplines. So that's the second tab. Sorry, I keep losing my mouse now. So Jennifer, I'm just trying to advance my slide here. Okay. Okay, thank you. So you can also look at the imagery layers by science disciplines, or finally you can look at it by featured layers. And these are the most popular layers or the new layers that have been added to Worldview. So next I'm going to give you a demonstration of Worldview. So thank you, Jennifer, for loading this. So firstly, when you go to Worldview and you close the welcome screen, what you will see is you see some black. So this is because the imagery isn't available for that day yet. So you can, if you want to see a full day's imagery, you can use the timeline at the bottom and scroll to yesterday, and then you'll see a full day's imagery. And you may notice that we've got these regularly spaced black gaps here in the imagery. These are between satellite overpasses. So, so the imagery for MODIS has these gaps at the equator, but if we put on the imagery for VIIRS, the corrected reflectance for imagery for VIIRS, which I've just done, then those gaps are not there because the swath is wider, so you don't get the gaps at the equator. All right, so I recorded this video on Monday. This was the day's image. And I can see here that we have a tropical cyclone. This is Tropical Cyclone Uesi. And I just wanted to show that if you were interested in this event and you wanted to share it, then there's this shareable link. Or alternatively, you can take a snapshot and make the image available to other users. You'll see here that you can choose which resolution you want the data to be preserved at. There are different formats, and you have the option of adding a world file. And when we've selected what you want, you can click on download and make that data available. Okay, so the corrected reflectance imagery that we're looking at here is particularly good for looking at events. And I just want to highlight the event tracker. So this is next to the layers tab. And here you are, you've got Tropical Cyclone Uesi, and this shows the track that the cyclone took. This is a great tool for looking at different events. Whichever one you click on, it will show you which layers are most useful for viewing that imagery. And so that's another great tool if you're just trying to look at different events. Okay, so the corrected reflectance imagery is, as I say, it's one of the most popular imagery to be viewed because it provides natural looking imagery. And here we're looking at a dust storm off the coast of Africa. I'm just adding in the coastline and place labels. So you can see that the dust is coming off the west coast of Morocco. As I scroll through, this particular dust storm lasted a few days. So you might decide that that's of interest and you want to share that with somebody else. So Worldview has this very nice tool here, this video icon, which enables you to prepare an animation. And I'm just going to go to the one that I prepared earlier. And you can see that this is now scrolling through data from the 24th to the 27th of August at 1 day intervals. And again, you can make this shareable. So another very commonly used imagery band combination is 721, and we looked at it for burnt area. But in this case, we're going to be looking at floods. So this is from the Mississippi area from the 2nd of February 2020. And sometimes it can be a bit difficult to know what's flooded, but Worldview again provides a very nice comparison tool. So here I'm looking at 2 different dates. I'm looking at the December the 4th, 2019, and comparing it with February the 2nd. It also has a spyglass ability. So if you prefer, you can kind of use this. So my main image is the flood, and then with the spyglass, I'm looking at the non-flooded area. So the other nice tool that's just recently been added to Worldview is this measurement tool. So here we are. You can click on it in the bottom right corner, and using this tool, you can use you can measure an area. So that's particularly good if you've seen a burnt area that you want to measure or flooded area extent. And also you can just measure the line, so you can measure from point A to B. And again, you can share these images if you want to. All right, so just moving along now, I want to look at the different projections that are available in Worldview. So you can switch to a polar projection using this globe at the top here, top right. So there's not much to see in the Arctic at the moment, so we're going to look at the Antarctic. And there was a particularly clear view of the Pine Island Glacier. So this is, I borrowed this screenshot from one of the Worldview stories. Pine Island Glacier is one of the fastest retreating glaciers in Antarctic. And you can see here that in the Worldview story, they've put together a comparison tool comparing so the start of the glacier breaking up to, so start of the glacier breaking up, you can just see it here, and then swiping back across. So this started breaking up in November 2018, and then we're comparing it with January 2019. And if we go back to my recent view, this is from February 2020, you can see that a lot more of the ice is broken up. So when you're looking at the polar projections, it can be quite difficult to distinguish between cloud and ice. So one way to get around that is to add on the corrected reflectance band combination 367. In VIIRS, this is the M3I3M11 band combination. And in this band combination, the ice shows up in red and the cloud shows up in white. So that makes it easier to distinguish between the two. So we are just zooming into that same area. So early on, we mentioned that Worldview is also useful for downloading data. So I just want to show you now how you can download data from Worldview. I'm just going to turn off the corrected reflectance imagery, the 367, there we are. So this is now showing the sea ice from Modus Terra. And if you want to download data, you click on that data, download data icon, and then you can start to see the granules that are available. I'm going to zoom out. As it's the poles, there's a lot of overlapping granules. You wouldn't get this if you were looking in the geographic projection. But you can select the granules that you're interested in, and there you can click on the download data icon. Again, you have to be registered in Earth Data Login to be able to download the data. But once you are, then you can download the data. All right. So the other thing that I wanted to show you in Worldview is I just wanted to look at the fires and in particular the smoke. So the active fire data that you're seeing here, red hotspot, this is the same active fire data that's made available from firms. But here you can see some of the really big smoke plumes that took place on the 31st of December. And then I wanted to highlight the aerosol index and the pyrocumulonimbus products that are available from OMT. So the aerosol index relates to the thickness and height of the aerosol layer. And most atmospheric dust and smoke events are within the 0 to 5 range of the aerosol index, which you can see here. But in extreme fires, heat can rise into the atmosphere with the potential for causing a pyrocumulonimbus event, which is essentially a fire-enabled thunderstorm. So the signal for pyrocumulonimbus can be much higher than 5. So this pyrocumulonimbus layer was put together by the OMT science team, and it provides values up to 50. which is particularly useful if you want to monitor some of these pyrocumulonimbus events. And here you can see how the smoke travels across the dateline. Okay. So the other thing that I just wanted to mention, one of the most frequently asked questions we get is, what time does the satellite pass overhead in my area, or what time was the imagery collected? So here I'm just showing you some of the orbit tracks that have been put on for MODIS Terra. So this is the ascending and descending orbit tracks. If you want to get these, add these to Worldview, you can go to the featured layers and you can click on the various orbit tracks here. So you choose the corresponding orbit track with the imagery, which I haven't done here in this example, so my apologies for that. But here you can see that the MODIS Terra goes across at 9:50 in the morning, and the nighttime image is 10:15. Okay, so I just wanted to mention that too. All right, so back to my slides now. Thank you, Jennifer. So the other thing that I just wanted to mention, Karen's already mentioned the Worldview snapshot. So that was the camera icon that you saw in Worldview. And Worldview is great if you want to share imagery. But if you're out in the field and you don't have a very good bandwidth, then you might want to use something else. And this is where Worldview Snapshots comes into its own. So as Karen said, it's a replacement for the rapid response subset. And it makes available the most popular layers. And so I just kind of wanted to highlight that. So there's the URL for that. And then the other thing that we briefly wanted to mention was who uses LANCE products and what for. So I'm just going to highlight a few of our users here. So LANCE products are routinely used by direct users who access the data for their own purposes, and by brokers who add value to data by combining it with other specialist knowledge and serve it to targeted end users. And this slide just shows some icons from some of those partner organizations. So here we have a slide from the NASA Disasters Program. This is run out of the Applied Sciences Program, and LANCE provides near real-time products to support disaster risk reduction activities before, during, and after a disaster. So along the bottom we have some examples here of the answer to surface precipitation rates, which are particularly useful for hurricanes and tropical cyclones. Then we've got the MOPIT carbon monoxide, which is useful for looking at the effects of fires and impacts on the air quality. The VS fire product, which we've already looked at. MODIS near real-time flood product, and NASA's Black Marble nighttime light product, which was particularly useful after Hurricane Maria in 2018. It was used in Puerto Rico to see where the electricity outages were, and was very useful for targeting help to people in Puerto Rico. This is an example of near real-time products for volcano eruptions. On the left we have some examples for Hawaii's Big Island, and on the right-hand side it refers to the ModVolc product, which is also made available through LANCE but distributed from the University of Hawaii. Okay, as Karen mentioned, the lightning imaging sensor is one of the newest products to be added to LANCE. It makes the lightning imagery data is available 2 minutes after the detection from the instrument, and it's being used by the Highway project. This is the High Impact Weather Lake System, which focuses on Lake Victoria in Africa. Apparently 5,000 individuals die, approximately 5,000 individuals die on the lake each year due to severe weather conditions and storms that they weren't aware of. So the Highway project is a combined project with the Meteorological Organization and many other organizations, and they're using the LIST data to deliver improved weather warnings to local communities through text messages and radio alerts and by educating communities. So that's a great application. Okay, moving on in the interest of time. Oh yes, I just had to include this slide. This was provided by our colleague from the LIST program. So it just shows there was an analysis done to see where the lightning hotspots are over the Earth. So here it is. It's over Lake Maracaibo in Venezuela. So you can see that square there. Hopefully that's where we get the most lightning flashes on Earth. All right. Two other examples. On the left, we have situational flood awareness that was put together by the UN World Food Programme, showing floodwater detected in September 2019. This uses a combination of MODIS near real-time flood products with the Sentinel SAR data. And on the right-hand side, there's an example of a GeoGlam crop conditions bulletin. This is from the GeoGlam project, which uses MODIS, among other data, to produce vegetation indices for crop monitoring forecasts. And it's a project that's been very well received. You can see the different color codes here. Green shows crops that are experiencing favorable conditions, and the red shows areas that have poor crop conditions. And this is being used by governments and ministers to plan for food shortages and make sure that everybody has access to food. Okay, moving on to the next slide. Conservation International is one of our broker partners. They take the data from firms and have their own fire alert system. They engage with users on the ground, and they have a subscription alert for users in Madagascar, Indonesia, Bolivia, and Peru. And then just finally, some highlights from the press. So here we have articles about the Australia fires from the BBC News, the Weather Network, and the Washington Post. All right, I can see that I'm running out of time here, so I'm just going to end there and just finish with this last slide, which provides you with some URLs and links so that you can go and have a look at the data yourself. Thank you.
Okay, thank you, Diane, and thank you, Karen. At this point, what we'll do is we'll transition to our final optional set of polling questions, and we'll give these questions about 4 minutes or so. We do have some short answer questions, and then from there, we'll move directly to the question and answer period. All right, so we will give these questions just a few minutes, and then we'll move on to the question and answer period. All right, thanks, everybody. Okay, everybody, at this point we will transition to the Q&A period. We did have a question earlier on. So the question was, and it might be that this question has already been answered, are there any near real-time data sets that are customizable in Earth data, such as reformatting or reprojecting? So Diane or Karen? Okay.
Sorry, Jennifer, could you just repeat the question?
Sure. So the question is, are there any near real-time data sets that are customizable in Earth data, such as reformatting or reprojecting?
So there are various tools that are available for reprojecting data from the different data centers. If it's imagery that I suppose it depends whether it's imagery or data. I think that's probably a question that we could answer offline. We could point you to some URLs which would enable you to do that. So there are some tools for NetCDF and HDF for reprojecting and converting the data. And as we showed with the Worldview snapshots, sorry, not the Worldview, yes, the snapshots in Worldview, you can get imagery in different formats. I don't know if that answers your question, but I'm very happy to follow up with you offline.
And so then there was a follow-up to that. Although several tools are available to convert NetCDF to TIFF and vice versa, which one is preferred by NASA? I think that's a question for offline. I don't know whether there's a preference per se, but Diane.
There isn't an official recommended tool, but I can try and follow up with some of the people that are more familiar with that and see which ones they would recommend. But I have been asked in the past and I haven't been able to get one recommended tool suggested.
Okay, thank you, Diane. The next question is it possible to download images automatically from the website using Python?
So some of the data centers may allow you to do it with Python. I will have to get back to you on that. You can certainly script to get the data. There are API keys, and you can use wget to get imagery automatically. So again, sorry not to answer fully, but I can certainly get back to you on that. But if in me getting back to you, if you could let me know which data sets you're specifically interested, that would be really helpful too.
Okay, wonderful, thank you. The next question is there a schedule for which products will be added to LANCE, and is that made available publicly?
So we're guided by the user working group as to which products are recommended, and then we work with the data centers and the SIPs to make those available. So we could make available a list of products that are going to be added to LANCE, but we're very much dependent on the data centers as to the timeline. So we could give an approximate timeline. But for example, the flood product has taken rather longer than we expected, but it is imminent now. So we don't have anything that's publicly available. But we could take that as an action to do that. So thank you for that question.
Okay, thank you, Diane. Are there any additional questions? Okay. So yes, whether or not this particular webinar will be made available again, I'm actually recording today's webinar, so it will be made available both on our NASA Earth Data YouTube channel. We'll provide a link on the NASA Earth Data webpage. There's I believe it's under Learn, and then the webinars, subheader under that particular component of the website, and then I'll also send a direct link, recording link out to all registrants and participants. So the next question here is, when will the Vera snow cover product be available in Worldview?
I don't have a timeline for that, I'm afraid. I'll have to get back to you. It is planned though. And the Veers products, they are being worked on now. Yeah, sorry. I'll have to get back to you.
Okay, wonderful. So while we're waiting to see whether or not there are any additional questions, I just wanted to draw your attention to the bottom right-hand corner of your page. You'll find all slide decks for this afternoon's presentation, as well as two of the videos. The Worldview video demo is a little bit larger, but I will upload that in just a few minutes here. And then I've included a LANCE one-pager fact sheet, as well as a firm's one-pager fact sheet, which really kind of outlines the key features and functionality for both of those tools. And to download any of those publications, what you would do is click on it, and then you'll be prompted with an option to download the file in question. All right, does anybody have any additional questions here? If there are no further questions, I'd like to thank today's speakers, Karen Michael, as well as Diane Davies. And then what we'll do is we'll leave the virtual meeting space open an additional 10 minutes. So if you think of something, please feel free to jot that down into the Q&A pod. I will forward the log to our speakers, so they will certainly be able to follow up with you offline. And then at the same time, I'll upload the final animation, which could take a minute or two. Okay, let me do one last check. I do not see any further questions, so we will log off from the audio component, but as I said, we'll leave the virtual meeting space open. All right, well, thanks to all of you for joining us, and thank you to our speakers. All right, goodbye, everybody.
Thank you. Bye.
Goodbye.